Welcome to 7.1. We're talking arithmetic sequences. In front of you, you have two sequences, two sets of values, each with their individual terms or values in a specific order. They follow some kind of rule or algorithm. It's your job to find the rule for these two. Pause and try to find the next couple values. Welcome back. We have 1, 3, 5, 7. You could notice they're all odd numbers. You could notice that 1 plus 2 is 3, 3 plus 2 is 5, 5 plus 2 is 7. So we're going up by 2's. Next value would be 9, because 7 plus 2 is 9, 9 plus 2 is 11, and 11 plus 2 is 13. Our next sequence, 10, 6, 2, -2, -6. We see negatives and we go into panic mode. We are going down. To go from 10 to 6, we went down by 4. From 6 to 2, down by 4. From 2 to -2. Now again, think number line. To go from 2 to 0 is 2 steps. To go from 0 to -2 is 2 more. That's 4 steps. So we're really going down by 2. -6 minus 4 is -10. Remember, with negatives, less is more. So the values are going to look bigger, but they're getting smaller because they're negative. -14, so I'm going to subtract 14 again. That's the biggest challenge with negatives. The values look big, but they're really small. They're getting further and further away from 0. -14 minus 4 is -18. On your own, take a moment, reflect on what we've observed, what we've noticed about these two sequences. Write something down. We're going to do a think, pair, share in class tomorrow. So right now, think. Tomorrow we'll share and pair. When you're ready, come back to the video. An arithmetic sequence. An arithmetic sequence is a sequence of numbers in a specific order. Has to go in a specific order. This isn't just some random set of numbers that have a constant difference between each term. Now the term is just a value in the order of the sequence. In order to find that constant difference, you're going to subtract at least 2 pairs of terms, subtracting the left term from the right term. The differences are all the same. If the differences are all the same, you have a constant difference. We have an example right here. Let's say you have a list of terms. You would do term 1 or term 2 minus term 1. Find the difference. Term 3 minus term 2. Find the difference. You might try and do term 4 minus term 3. Find the difference. If these differences all come out to be the same, you have a constant difference. That means you have, or a constant difference, that means you have an arithmetic sequence. Let's try this together. I'm going to take term 2, which is 3, minus term 1, which is 1. Subtract them, I get 2. I'm going to take term 3, which is 5, and subtract term 2, which is 3. I get 2. As long as you're subtracting a value on the right minus a value on the left, you'll always get the constant difference. The constant difference in this case, because they're both 2, my constant difference is 2. Always right minus left. So let's take 6 minus 11. I should get, careful, this is a calculator moment, 6 minus 11, I get -5. Let's try -4 minus 1. I'm always subtracting. Don't assume because you see negatives that suddenly subtraction is out the window. -4 minus 1. Again, if you struggle with negatives, that's a calculator moment right there. You get -5. I have the same difference, so I have a constant difference. These are both arithmetic sequences. On your own, try to find the constant difference for both of these two terms. Pause the video and come back when you're done. Remember, in order to receive credit on the you try sections, you must show your work. Use your calculator to find your answer, but prepare for the calculator moment by showing your work. Welcome back. If you did your job correctly, you should have ended up with a constant difference of 6. For number 2, you should have ended up with a constant difference of -8. If you have any questions on these, we will go over them individually in class. Now, to find a specific term, the best way to do this is start by finding the constant difference. We have 6 minus 4. That gives me 2. I have 8 minus 6. That gives me 2 again. So I know that it's going up by 2. The first term in the sequence, well, I can just read that one. It's there. 4. The next term, the fifth term, that's 1, 2, 3, 4, 5. So I'd have to add 2 to 10. 10 plus 2 is 12. The 30th in the sequence, well, if the fifth was 12, I could start by just adding 2 plus 2 plus 2 and keep going until I hit 30. But that, to me, sounds like a pain in the butt. I'm not doing that. There's always an easier way in math, so we're going to find it. We're going to learn a little formula for finding any term in an arithmetic sequence. This is the general formula of an arithmetic sequence. You need to find a couple pieces of information. You need to find the first term, which is always just given to you. It's the first term in the set of values. You need to find the constant difference, which we know we can do by just subtracting right, left, right, left. So take our constant difference. And this is just a matter of plugging and chugging. We end up creating an order of operations problem. So your answer is what all of this calculates out to. It's the first term plus, and in brackets, and then in parentheses, n, which is the term number you were looking for. We were looking in the last example for the first term, for the fifth term, for the 30th term. So it would be 1, 5, or 30 minus 1 times the constant difference. So let's try finding a specific term here. We need to find the first term in the sequence. That's given to me. It's 3. Constant difference. We subtract a couple. 6 minus 3, you get 3. 9 minus 6, you get 3 again. So I have a constant difference of 3. Now I need to set things up. I need to make sure I'm setting up my equation correctly. Always start, whenever you're dealing with a formula or an equation, start by writing it out. Write out the general form. So in this case, we have a plus bracket, parentheses, n minus 1, parentheses, times constant difference. Now I'm going to go back and replace everything. A is my first term, so that's 3, plus bracket. I'm looking for the 11th term, so 11 minus 1, times the constant difference of 3. What we've just created is an order of operations problem. Remember, we have a 3-step process for the order of operations. We follow the rules of PEMDAS, parentheses, exponents, multiplication, division from left to right, addition, subtraction from left to right. In order to do this, we underline, we evaluate, we rewrite. All 3 of those steps help us organize our work properly. 11 minus 1, I start there because it's parentheses. 11 minus 1 is 10. I underline, I evaluate, I rewrite. Everything that did not change, everything that did not get evaluated drops straight down. 10 times 3 is my next step. I get 30. Those parentheses are now done. I'm left with just 3 plus 30 gives me an answer of 33. So the 11th term, if I kept adding up 3 every time, 12 plus 3 plus 3 plus 3 plus 3 plus 3, until I got to 11, I would end up with 33. I'm going to do the exact same thing and find the 30th term in the sequence. The 30th term. So just like every time you deal with a formula, whether it's in algebra, in geometry, in physics, you write out the formula to start with, so you know exactly what goes where. N minus 1 times D. I'm going to plug things in. You hear me call this plug and chug. The chug is the order of operations. 3 plus, 3 being my first term in the sequence. N is my 30th term, so I'm going to put in 30 minus 1. 1 is always just 1. Times my constant difference. My constant difference in this case was 3. We found that by subtracting. Now I've created a nice little order of operations problem for myself. 30 minus 1 gives me 29. I underline, I evaluate, I rewrite. Everything that did not get evaluated or changed comes straight down. We're not doing a new problem, we're just turning this problem into a simplified version of itself. I underline, because I'm still in parentheses, I evaluate, I rewrite. 29 times 3 gives me 87. 87 plus 3 should give you 90. So the 30th term of this sequence is 90. This is how you do every problem. You find the first term given to you. You find the constant difference by subtracting. You write out your formula, plug and chug. Write out your formula, plug and chug. On your own, go ahead, pause the video, try this sequence. Find the first term, the constant difference, and using these two pieces of information, plug and chug into the formula. Pause the video and come back when you're ready. Remember, in order to receive full credit on the You Try section, you must show work. Welcome back. Our first term in the sequence ended up being 3. The next term in the sequence, or sorry, not the next term, but the constant difference should have been 2. If you plugged everything in correctly, you had a constant difference of 2. A first term of 3. We're finding the 15th term in the sequence. You should have ended up with 31 as your 15th term. Negative third, now it doesn't matter if I'm going forward or backwards. If you can go backwards in a sequence, that's really all the negative third sequence means, or negative third term. As long as you plug it into the formula correctly and calculate it out correctly, you should not have an issue. So, your final answer for the negative third term would be negative 5. If you have any questions on this or the Try Together section, please let us know in class.